Great, and we are now live on YouTube. Our participants keep joining, so please, we are ready to start with our fifth session of the SG Learning Center. Thank you so much for joining.
Well, great, everybody, and good morning to everyone who's out there with us. We're going to be getting started here in just a couple minutes, but what we want to do before we get started with some of our presentations, involving our oceans and the interactions with land, we want to learn a little bit about our audience here. So in the chat, I'm throwing in a quick little message for everyone. We have a survey in there that we'd really like to, again, learn a little bit about everyone. Where are you coming from today? What's your SDG of interest, as well as maybe some of what the knowledge you bring, because we want to be able to best provide for everybody. So as you fill out the survey, you can either click the link, or with your mobile device, you can scan the QR code on the screen, and you'll be able to answer these couple little survey questions, and we'll start to see everyone who's a part of our global community here today. So we'll go ahead and we'll give a couple minutes before jumping into our first presentation. So again, as everybody's slowly coming in, good morning, or good afternoon, or good evening, wherever you're coming in from. We have a little survey just to learn a little bit about everyone. So if you could either scan the QR code that's on your screen there, or you can click on the link in the chat. We'd love to learn a little bit more about our audience, and we'll see your results appear on the dashboard. Really get a sense of who we are as a global community. See some people coming in from the Northeast United States, as well as some folks from, looks like Greece there in the Mediterranean. Don't be shy, don't be shy. Man, got some more people coming in from across Europe, and again here in the Northeast. We really want to see our global community, where everybody's coming from, what's of interest to you. Always exciting to know that we're all, on the same team working together for our sustainable development goals. And if you want, I've also shared the link to this dashboard yourself. So if you want to see it and even explore a little bit of it yourselves, even have the ability to click on some of the different elements in our dashboard. If you want to see where in the world someone's interested in SDG number 10, you can see that's coming in from northern France. And we'll give this again just a couple minutes for everyone to fill out that survey. There's a couple of really great questions in there from Stella and George, our first presenters, just asking to learn a little bit about what you consider to be some of the biggest human-induced problems on the marine ecosystems, how climate change impacts the oceans, which areas or operations does the maritime industry need to improve, and what do you think are some of the main impacts of COVID-19 on the oceans? Just some basic keywords maybe you want to throw in there. See what kind of collective knowledge we have as a global community. And again, you can either scan the QR code with your mobile device, or I'll also again share the link to the survey and to this dashboard in the chat with everybody. Got someone coming in from the Middle East. Again, a bunch of people from Europe, the eastern seaboard of the United States. We got some Southeastern Asia coming in as well. Man, we really got the whole globe represented here today. So we have 20 surveys. Let's see if we've got any information here regarding some of those keywords that you put in here. So I'm going to quickly go through and reload some of these, see if we have some information here in our word clouds. Look at this. We've got some word clouds. Check this, guys. So this is exactly what we were looking for. All right, looks like we're maybe waiting for some more responses for some of those later questions. We might not have enough responses there yet. Yeah, we need a couple more responses in order to show some of the information. But again, we can see some words coming in for pollution, plastic waste, fisheries, transportation. Excellent, excellent. So Stella and George, I'll leave it to you if you want to see if anyone else is willing to fill out our survey before jumping into it. But we've got some good responses, got some good information there. People really chiming in from all around the world, sharing what they think are some of those biggest human-induced problems or climate change, acidification, biodiversity, probably rise in terms of temperature, plastic and pollution. Some really, really phenomenal responses, everybody. Let's see if we got anything. Okay, it looks like we still don't have necessarily enough responses for those questions, but still think it's pretty powerful. But George and Stella, do you want me to turn it over to you two for our first presentation?
Yes, please.
Excellent. I'll go ahead. I'll stop sharing my screen and I'll turn it over to our first presenters.
Okay, let me share the presentation. Allow me a minute. All right. Hello from me too. This is session 5 of this very interesting event. Session 5 is on the SDG number 14, the Sustainable Development Goal number 14, about protecting the oceans. Life underwater is a goal. So we are going to talk today about this SDG 14 and its interlinkages. It is three presenters in this session. The first one is Eric Wagner, who had just talked and presented the poll. He represents Esri, and he will talk to us about ArcGIS and how can we use this very useful, this very powerful tool in our effort to protect the oceans. And it is another 2 presenters from the American College of Greece. One is myself. I'm Stella Apostolaki. I'm Assistant Professor of Environmental Science and Executive Director of the Center of Excellence in Sustainability at the American College of Greece. And my good colleague, Dr. George Kokosalakis, who is also Assistant Professor of Entrepreneurship and Shipping, and he is Executive Director of the Center of Excellence in Logistics, Shipping and Transportation. The 2 of us representing the American College of Greece, we will discuss with you how the maritime industry is connected to the marine ecosystem, and we identify this relationship as a love-hate relationship. So I will start by discussing the issues that they are related to the marine environment. Of course, the problems that they have been introduced in the marine environments due to human interventions are several, and we would have needed many hours to analyze all of them in very in depth and in very big detail, but we will try to have an overview today of how we have affected the marine environment, how we humans have affected the marine environment, and what can we do to, if not reverse the situation, but to support the oceans. As we have seen in the questions, that Eric shared with all of us at the beginning, climate change, of course, is one of the big issues that we are facing. And there was a question asking about which are the main impacts of climate change to the oceans. Most people identified rise and sea level separately into words. So actually this is one answer, sea level rise. Ice melting and sea level rise is probably the most recognizable impact of climate change related to the oceans. Of course, ocean warming is a very big issue since the global temperature is rising. Obviously, the temperature of the seawater is also increasing. This is particularly true for the surface of the sea. So the surface seawater has higher temperatures. This creates an obstacle for the right mixing of the different layers of water, and this has an impact in the supply of oxygen and nutrients for marine life. So ocean warming is affecting the way the oxygen is dissolved in the water, the way nutrients are transferred to the different aquatic organisms, or even how the nutrients are produced and how the food chain is supported. On top of these changes in the oxygen, in the nutrients, and in the different elements of the water, the temperature rise is causing marine heat waves. This is a relatively new finding. We were mainly talking about heat waves on land, the atmospheric heat waves, but lately we are talking a lot about the marine heat waves. They are very similar to the atmospheric heat waves. There are areas in the ocean where we identify very high levels of temperature rise. And these changes in temperature particularly harm the more sensitive species, the indicator species like corals, like the kelp forests, and of course they affect the whole chain of life in the marine environments. The ice melting and sea level rise, which as we've said was identified by most of you as the biggest issue. I don't know if the answers have changed now because I don't see the dashboard, but correctly it was identified as a very big issue relating to climate change. When we are talking about ice melting, we have to keep in mind that we are not only talking about the melting of the ice caps, but also melting of glaciers. So we have mountainous glaciers and ice coming from the mountains that melts, joins the rivers and ends up in the sea. So any kind of ice melting contributes in more water in the sea, and it affects sea level rise. There is a projection that if we manage to restrict the increase on average temperature to 1.5 degrees Celsius, the Arctic Ocean will have a sea ice cover in September, almost every September. We talk about September because this is the month where we have the lower levels of ice in the sea. We're talking about the Arctic Ocean, which is the ocean in the North Pole. If the temperature increases up to 2 degrees Celsius in comparison to pre-industrial years, then we will have ice every second or every third September in the Arctic Ocean. So we understand that a half degree increase in temperature makes a very, very big difference for ice and for the climate and the environment. During the past century, the 20th century, the global mean sea level had already risen by about 15 centimeters. And if we carry on with big numbers, big amounts of emissions, many tons of carbon dioxide as we do today, we may expect that by the end of the century, we may see 1.10 meters sea level rise. And in these two graphs, we can see how the ice has melted. Maybe I could hide this. Yes, how the ice has melted in the Antarctica and in Greenland just in the past 15 years, from 2004 up until 2020. We can see the amount of ice that remains and how does this continuously reduce. There is a very interesting video. I'm not sure if we can see it. Oops, excuse me. This is a video from NASA where we can see, I will start again, and we'll talk it through very fast. It is a short video in which we can see the ice melting, also in a graphic format, but also as we can see the map of the Earth, and we can see how the ice melting has been reducing again in the past 40 years. We can see there is some fluctuation from year to year, but there is a continuously decreasing trend in the ice cover. So continuing with the impacts of climate change in the oceans, we have already talked about sea level rise, about the global mean sea surface temperature. We can see that the sea level is rising, temperature is rising, the number of heat wave days in the oceans is rising, the ocean heat content is increasing, and on the other side we have ocean oxygen, dissolved oxygen, which is in decrease, and we also have a drop in the surface pH. What does this mean? Drop in the pH means more acidic environment, which may affect wildlife and the different species and the ecosystem as a whole. How does this occur, this ocean acidification? When carbon dioxide is entering the water bodies, it is reacting with the water, and it is making the water, if we can describe it in a simple way, much more acidic. It drops the pH. And this, as we have said, have a very negative impact in many aquatic species. One other issue which is very important is for us to understand that the oceans produce 50% of the world oxygen. Half of the oxygen that we need on land is produced in the oceans, and it is produced through photosynthesis by plankton, which is photosynthetic plankton, the phytoplankton, and by aquatic plants. The more carbon dioxide is absorbed by the atmosphere, the more the water becomes saturated with carbon dioxide, and the more the oceans stop acting as carbon sinks. Of course, the oceans always have the ability to absorb a lot of carbon from the atmosphere, but this ability reduces as the carbon dioxide increases in the atmosphere. The impacts on biodiversity, as we've said, are very important. They are highlighted, and this is a priority if we want to protect our ecosystems and oceans. You will excuse me. I apologize for that. The videos were running at the back. Okay. In this slide, we can see the different interconnections, the interlinkages, as we referred at the beginning of the SDG 14 and the different ecosystems. There is obviously a direct link between all ecosystems on the planet, and there is a link between the cryosphere and the oceans. That's why the IPCC, the Intergovernmental Panel on Climate Change, has produced the report on the ocean and cryosphere in a changing climate, where what is underlined in this report is how the melting of glaciers supports sea level rise, and also how this interrelation can affect even the marine heat waves, the pH, the ocean oxygen, the dissolved oxygen in the oceans, the ocean heat content. So as you can see, several indicators are increasing, some others are decreasing. All of them together contribute to very big issues, concerns that relate to the oceans. I would like now to leave the topic of climate change because it is endless practically, and go to other human factors that affect the oceans. Going back to the questions of the poll, to the poll that we had at the beginning, we saw that some of the impacts that were identified by many of you were related to garbage, to solid waste, to pollution in the oceans, any sort of pollution. So let's start with the plastic threat. I'm sure most of you have heard about the garbage patches. There are patches in the oceans, especially in the Pacific Ocean, where we find very high accumulation of plastic waste. It is estimated that 1.15 to 2.41 million tons of plastic are added every year in the oceans coming from the rivers. Plastic items have even been identified at the deepest point of Mariana Trench, which is again in the Pacific, and it is at 11,034 meters, 11 kilometers depth. The Great Pacific Garbage Patch covers a very big area. It covers an area of approximately 1.6 million square kilometers, which is an area twice the size of Texas and 3 times the size of France. And we have to understand that it is not only the extent, the surface that we have to take into consideration, but it is the garbage patch goes to a great depth inside the ocean. And of course, it is very, very difficult to remove this garbage, which is dispersed in the ocean. When plastic waste remains in the ocean, of course, it does not biodegrade, as it is material which cannot naturally degrade, but it breaks down into smaller pieces. And these pieces are the microplastics. Microplastics are particles which are less than 5 millimeters in size, like biophenol A, biochlorinated biphenyls, and other small particles. And particles may even break down further into nanoparticles, which are particles of size less than 1 micrometer. Of course, we cannot see the nanoparticles with naked eye, but they are in the water, they exist there, they enter the food chain, even human food chain. And according to recent studies, a very big amount, a very big percentage of the salt, of the sea salt that we consume is not actually sea salt, but it is nanoplastics, nanoparticles, which are not natural ingredients that we should consume. Another very interesting case that shows how much plastic waste is remaining in, for how long it remains in the ecosystems and how persistent plastic wastes are, is the case of barnacles that they may grow on plastic material. This picture was taken by a student of ours at the American College of Greece, and it is a plastic ball which was produced in Spain. It was found in Greece, and there was a barnacle that had grown on it, which is a species which is naturally found in the Indian Ocean and the South Chinese Sea. So we can understand that the plastic ball remained in the sea for a while, and it has made a very interesting travel around the globe. Similar to microplastics are the microfibers. They are, again, small particles that they result from the degradation of synthetic textiles such as polyester. The microfibers are coming from the textile and the cloth industry. They enter the oceans, the rivers, and the oceans, even through washing of our clothes. Most of the microfibers come from polyester. Approximately 2 million tons of microfibers are released into the ocean every year from various sources. 13 million tons of coastal synthetic fabric waste are entering the ocean every year. Out of the 2 to 2.5 million tons that they come through the rivers, and 1.5 million, trillion of microfibers are estimated to currently be present in the oceans. Again, they are tiny and they are entering our food chain. The impacts of agriculture to the oceans, the excess amount of nutrients that they are found in chemical fertilizers are entering the oceans. Those nutrients are primarily nitrogen, phosphorus, and potassium. They cause a phenomenon that we know it as eutrophication. It means excess growth of aquatic plants, algal bloom, and hypoxia. Hypoxia is a condition where there is not enough oxygen in the aquatic ecosystem. We have a very big consumption of oxygen due to this algal bloom. So we have what we call oxygen sag. And the next step is the dead zones, zones where species cannot survive, and especially fish cannot survive. It is estimated that more than 400 extended dead zones are identified in the world oceans. It is a very big number. Pollution. We have already talked about plastic pollution and garbage. We have already talked about pollution from agricultural activities. There is also pollution, obviously, from human sewage from our urban areas, sewage that may enter the oceans without any prior treatment, pollution from transportation, from ballast water, from oil spills, from the efforts to extract oil and hydrocarbons, from grounding, from toxic waste, industrial waste. All of this waste enters the oceans. Coastal erosion is a natural thing, provided the sea level rise. It is a phenomenon that it is increasing, and it is increasing dramatically. The reasons are several. The main reason is the sea level rise and the extreme phenomena which are related to climate change. But there is also the excessive coastal development that contributes to coastal erosion. The higher the coastal erosion, the higher the risk of flooding from the sea. A lot of coastal areas are affected by coastal erosion. A lot of species that have their nests on the coast are affected by coastal erosion. Such species are sea turtles, seals, and many other species that they use the coastal area. And there is also a very big threat to the coastal historical monuments. Actually, the protection of the historical monuments, of coastal historical monuments, has been prioritized by UNESCO right now. And the reason is that there are a lot of monuments in coastal areas all around the world. Many of them, they have already been affected. Some of them have been destroyed, and some others are threatened. And we shouldn't forget the other very big issue of overfishing, which is actually the phenomenon where we are removing huge amounts of fish from the oceans. Of course, many claim that we need the fish in order to feed the human population, but on the other hand, there is a lot of waste of fish that is removed from the oceans. According to many analysts and researchers, the year 2050 will be a very critical year, will be the year where the world fisheries may collapse. This collapse means that we will have a reproduction, a new generation of fish that is not enough to keep an active population in the oceans. Fishing and this reduction in fish stocks and the impact on fisheries has a very high cost, monetary cost. It costs $50 billion every year at a global scale. And of course, we can understand that this is a very big economic loss, especially for countries and regions which primarily depend on fishing within their economic activities. 57% of the world fish stocks are already fully explored. In Greece, where I'm talking to you from, this number is much higher. 76% of fish are being threatened by intensive fishing, and 90% of large fish are being fished beyond their safety survival limit. This is also attributed to the fact that that Greece is in the Mediterranean Sea, which is a closed basin, so the ecosystem does not renew so easily as in the open ocean. 300,000 whales and dolphins are killed each year via bycatch, meaning accidentally and not targeted. So this is a huge number. And 90% of predatory fish like tuna, sharks, swordfish, cod are gone. So this means that we are left with only 10% of those species. And on the other hand, only 2% of the world's oceans are protected through protection schemes, through marine protected areas. So this is something we should do something about. This overfishing is attributed to fishing techniques which are inappropriate, like bottom trawling, like dynamite fishing, massive fishing techniques, and bycatch. As we have said, fishing out of season, meaning fishing during the reproduction season that does not allow the new generation of fish to reproduce. And of course, we all have a share on that. It is our consumption habits that contribute to overfishing, consumption habits which are related to a lot of waste, to a culture of wasting food and wasting even species and living organisms, or a culture of trying different and very rare species, seafood, rare seafood, or a very young seafood. So as we have said, overfishing is a very, very big problem. The yearly growth of fish consumption is 3.1%. This means that we still have an increasing rate in consumption. However, we should try to limit this because there is a very big share of the world population who use fish as the main source of protein, and they are in need of a healthy ocean, big amounts of fish in the oceans. So it should be wiser for all of us to buy fish or consume fish in a more sustainable way. As you can see, 3 billion people are those who rely on fish as their primary source of protein. Fisheries contribute to very big amounts of money, to $274 billion is the gain from fisheries if we protect them. We may even gain an extra $50 billion per year if we to make our oceans more sustainable. And of course, this will support more of the people who are actually in need of this type of food. And the last thing that I would like to cover is how the pandemic, COVID-19, has affected the oceans. At the beginning of the pandemic, I believe most of us remember that there was a very big discussion about how the pandemic and the lockdowns had contributed in a revival of the environment and the ecosystems. Many people thought and many expressed the feeling, the idea that the ecosystems will thrive after the lockdown because human activity was reduced. But this is not the case for the aquatic ecosystems and for the oceans. We all know that plastic waste has increased dramatically. We use masks that they contain plastic. They are the material they are made of contains plastic. We use plastic gloves. We use a lot of single-use items. We were instructed for the first time after many, many years to use plastic cups or plastic bottles and then immediately dispose them in order to not recycle the coronavirus. This has resulted in generating more than 1.6 million tons of plastic per day on a global scale. And of course, all this plastic, which is produced on land, is not recycled. Masks and plastic gloves are not recycled at all. We were instructed not to recycle them, and many of them end up on land, in the rivers, and in the ocean. So the lockdown had a very negative impact for aquatic species, that they may be trapped in plastic waste, or they may mistakenly consume some of this plastic waste, as the sea turtles do, and they choke and they find a very torturing death. Even disinfectants that we use extensively, they have an impact on aquatic ecosystems. The disinfectant wipes, they are soaked in harsh chemicals such as bleach to preserve their structural integrity. The wipes are often made with a durable blend of cotton and plastic, such as polypropylene and polyester, and this remains in the environment again for many, many years. Disinfectant wipes can take up to 100 years to biodegrade. Once they are sprayed, the sanitizing solutions enter the water cycle through the sewer system in the form of runoff. The chlorine-containing bleach that has been used extensively in street disinfection can be very toxic to aquatic biodiversity. And also the chlorine disinfectants promote microbial and antibiotic resistance in waters, which is another very dangerous thing, because this might mean that several diseases may develop in water, and they may affect different species. At this point, I would like to pass the floor to my good colleague, Dr. George Kokosalakis, who is going to talk to us about the maritime industry and how does this affect the environment and our lives.
Thank you, Stella. Thank you for the excellent presentation and introductions that you allowed us. And good afternoon, everybody. Good morning, everybody. I've seen on the dashboard that you are coming from all edges of the world. So thank you for attending. And as we started, I mean, it is the session started as, you know, the presentation started at maritime industry and ecosystems, and it is a love-hate relationship. So in this presentation, we shall discuss about the maritime industry, and that the maritime industry has everything to do with the ocean. So Stella, next slide, please. In this brief part of the presentation, I guess we shall be discussing about the maritime industry and of the human operations that are taking place within the maritime industry, and essentially the negative environmental effects that they do have on the marine ecosystem, and what options or what recovery attempts we do have in order to make things better. Next slide, please. Let's see first things first. Let's see why we care about the maritime industry. Well, the maritime industry is all about transporting goods via the sea. And it is important because more than 80% of the global trade is taking place via vessels, via the maritime industry. And why is that? Because it is more efficient, because of economies of scale. We use large ships. We transport very large quantities at a significantly low cost. The workforce, the labor that it is required to transport 1,000 containers is significantly less than having 1,000 trucks carrying one by one of these container boxes. And well, imagine, I mean, this huge vessel that you see over there, this Costco vessel, essentially it is carrying some 14,000 boxes on a single trip, having some 25, 30 maximum crew members, while you would need 14,000 drivers, and you would need a queue of about 60 miles just to transport the same amount of container boxes around the world. So you can imagine the effect. And well, with respect to other modes of transportation, it has a relatively low environmental footprint. We shall explain that later, but yes, it is a little bit more efficient because of economies of scale, this environmental footprint. Next slide, please. But again, the thing is that with this, please press to move on to all of them. Unfortunately, we had this. There's one more. Okay. Excellent. So the maritime industry is liable for pollution, air pollution to start with. It emits dangerous or toxic oxides like sulfur oxides or nitrogen oxides in the air that are, some of them are poisonous for humans or toxic. It is liable for greenhouse gas emissions. It is liable for pollution of the sea via oil or solid waste, throwing garbage into the sea. Again, it is liable for migration of non-indigenous species from place to place, species that are traveling along with the vessels and they are discharged in a different place around the globe. We shall discuss this at the very end, or even underwater noise. Air pollution, next slide. Air pollution. Well, have you seen a picture like this? Well, on purpose, I distorted a little bit the image because I didn't want to penalize any vessel, and I tried to remove the name of the vessel. But this is a regular thing in the maritime industry. Obviously, this vessel has some kind of malfunctioning part at the main engine, but nevertheless, this is an ugly image that we see very frequently around ports. And this smoke, it looks worse than what actually is. It is liable for many lung diseases. It is liable for smog. It is not that toxic, to tell you the truth, but it certainly pollutes the environment around ports. And do you think that only dirty old bulk carriers, very old vessels, are producing this kind of emissions? Well, not really. Next slide, please. Even fancy smancy cruise ships idling, not moving, waiting to load or discharge passengers in a tropical paradise somewhere in the Caribbean are producing smoke. Why? Because they have internal combustion engines running at all times to generate power, to propel, to do things that are required. So keep that in mind when we shall discuss a solution later on. So what it is that it is produced out of these exhaust, or what are all these exhaust fumes? Next slide, please. Well, obviously out of fossil fuel internal combustion engines, we certainly produce greenhouse gases like carbon dioxide. If we burn alternative fuels like natural gas, we produce methane. In general, if the engine is malfunctioning somehow, it produces nitrous oxides or sulfuric oxides, or all types or different types of gases that are, well, not that healthy for humans. Is it all that bad? Next slide, please. If we collectively see all greenhouse gases around the globe, well, you will see that 73% of this is the cumulative carbon dioxide emissions around the globe. It was compiled in 2020, but it was referring to 2016, not very far back from nowadays. Energy is the main reason for carbon dioxide emissions around the globe. And what you see is that, well, iron and steel, massive energy used in buildings, massive. Shipping, according to this study, it was only 1.7%. And well, studies around the globe, depending on the way that they are accounting for things, they indicate anything up to 2.5, 3% is the maximum that I have seen. It was an over pessimistic study accounting for, you know, the shipping industry for 3% of the global carbon dioxide emissions. Well, so you will tell me, yeah, George, why should I care about the maritime industry? 1.7% is nothing. Well, not really, because, next slide, please. Shipping industry is mainly taking place around ports for a great period of time, and then we have vessels traveling through the oceans. And what do you see? You see that around ports, I mean, this is an image, it is a composite image of the tropospheric nitrogen dioxide as it is observed from satellites. And you will see increased concentration of this tropospheric nitrogen dioxide, but you will see also a few routes in the middle of the ocean having increased concentration. And over here, unfortunately, I cannot move my mouse here, but you could see a shipping lane connecting the northern tip of the Straits of Thailand with the southern tip of India and Sri Lanka. And this is a popular shipping line. From the other side of the Thailand Straits, you'd see a few lines crossing towards China. Again, all these are areas of concentration, of shipping routes concentration, and this is the only way that we can actually explain those kind of concentrations. And if we go to the next slide, you will see the popular shipping lines are exactly on these kind of routes. Well, it is a different orientation of the globe now, but these are all the routes for large commercial vessels, vessels that they do have from a certain percentage of tonnage and upwards, over a year. So these are all the routes of all vessels throughout the year. And you will see that there is a concentration of routes of vessels around the globe. And do you see from the Thailand Straits all the way to the southern tip of India, this bold red line that we can construct here from this route. So if we overlay those two charts, you will see that wherever we do have vessels, we have increased concentration of nitrogen dioxide. And if I was presenting to you carbon dioxide, it would have the same image. If I would there to present to you sulfuric oxides, it would be the same image. So we do care about the maritime industry, even though we are producing using vessels less than 3% of the global carbon dioxide emissions. Nevertheless, not everything is bad in this kind of operation. If we compare it with other modes of transportation, next slide, please, we will be able to see that it is more efficient than other modes of transportation. So here you see that vessels, large container ships or large bulk carriers or large tankers, because of economies of scale, the carbon dioxide emission intensity, which is grams of carbon dioxide per mile transported, per ton of cargo transported. So because of economies of scale, they are quite efficient in transporting large quantities of cargo from place to place. An order of magnitude higher are trucks from, we see vessels running from 3 grams all the way to almost 8 grams. Trucks are 80 grams in order to transport a container box from one place to the next. Let's not discuss about aviation at all. And if we would have to correlate to trains, then there would be commercial trains are around 35 because they are diesel electric. Passenger trains are less. Well, and then you will tell me, okay, did COVID have any effect on this? Well, yes. Thank you, Stella, for changing this. Here, this is a representation of the Long Beach, California, Anchorage area, where we see all these green dots representing vessels which are idle off port limits or within port limits, waiting in line to load or discharge cargo. And COVID did affect supply chains, did affect port operations. And we had, I mean, this was not the worst, the worst case, the worst day. I mean, this is on a regular day. We had reports that claimed 130 to 170 vessels per day waiting around the port area, having their diesel generators running, by the way, in order to produce electricity, dropping garbage, polluting the sea in various ways. And well, the next slide projects an image of this area, having vessels idling, waiting for their turn to get into the place. And you will tell me, come on, George, is it only in the United States that bad? Well, no. In China, it was even worse. Again, popular place. Next slide, please. You will see that this is a very busy area. Stella, next slide, please. This is a busy area around Shanghai and Ningbo, Jiusan, two of the major ports in China. And you would see that we have thousands of vessels waiting in line or drifting, either as dots or either as vessels. You will see them over there, waiting their turn to get into the plane, into the port to load or discharge. These are areas which are essentially affecting pollution. Next slide, please. So what do we do? The International Maritime Organization, a United Nations agency about safety at sea, this has established a very ambitious target to decarbonize the maritime industry within this century. And the targets are a reduction of 50% up to 2050, even zero emissions, very ambitious, up to 2100, or decrease intermediate targets, 40% reduction of carbon intensity, carbon dioxide emitted by a ton mile, up to 2030. Is this feasible? Well, maybe yes, maybe no, but technology is there to assist us. And there are a few options that we are actually developing as we speak in order to make things better for the oceans and for life near ports. Students at the American College of Greece have already explored these areas and have presented their results. Some of these shall be presented in what follows. So next slide, please. One way is to use filters or modern engine designs to capture all these harmful oxides like sulfur oxides or like nitrogen oxides, or even use fuels that they do have low sulfur fuel. Are they applicable everywhere? Well, not really, because, okay, these filters are quite expensive. Low sulfur fuel is more expensive than regular fuel. And these are technical matters, but what is the applicability of these regulations? Next slide, please. We will be able to see areas where this is applicable. So it is applicable in northern in United States and Canada. It is applicable all around Europe, and regionally in a few areas in China, and that's about it. The most part of the globe is left off. Not because IMO left it off, because regional governments did not take the initiative to enforce these kind of regulations. So this is important for us to know that, okay, yeah, we are doing things, but unfortunately, regionally, with respect to this effect. Other methods. Next slide, please. Again, regional regulations. Here we have the example of the Port of San Diego have established areas where vessels have to slow down a little bit, meaning that the reduced engine load would reduce fuel consumption and consequently less emissions. This is applicable, in the United States for San Diego, Los Angeles, Miami. Several ports around the globe have introduced similar ways of reducing emissions around ports and essentially improving the air quality near those ports. Next slide, please. Other ports have introduced ways in order to allow vessels to turn off their diesel generators. So they are providing power outlets to vessels. Vessels can completely turn off their diesel generators for the production of electricity and connect to shore power. Obviously, this does not alleviate completely the problem, but it mitigates the issue somewhere on land where we can control better the energy production mechanisms, and obviously we can take advantage of renewable energy sources. Next slide, please. Other alternatives is to use alternative fuels, something that our students have extensively also analyzed, and we have identified, and the maritime industry has identified several alternative options of fuels that have less environmental impact, lower carbon content or carbon footprint when they are burned. So we have a transitional set of fuels that have lower impact on the environment that can be used immediately, like LPG or LNG or even hydrogenated vegetable oils. Some promising options like ammonia or hydrogen or even electric ships. All of them, they do have their own benefits and barriers and concerns, because imagine yourself having concentrated ammonia or concentrated hydrogen along with you, carrying a few hydrogen bombs essentially with you all around. The results will be devastating in case of an accident. Electric ships, they are far away because we cannot concentrate that much power within batteries. But yet again, technology is being improved, or using renewable energy sources like the wind, wave, or sun. And these are not far-fetched. Next slide, please. We can use hybrid combinations of LNG and solar panels and wind, or even, next slide, assist navigation by using renewable sources, and obviously paying the penalty of being a little bit slower. But attempts and designs that can assist navigation and can decrease the carbon footprint are there, like kite sails or Fetner rotors, or these blades that you see on the two lower vessels that are essentially like blades of an aeroplane, like aeroplane wings that are propelling vessel forwards. So technology is there. It is in our hands to use it. Next slide, please. A few alternative options. Each one has its own barriers. It is very technical discussion, but I'm available for anyone to discuss further our options and what we believe that it is the most promising one. Let's move to the regulatory phase. So next slide, please. What we can do to improve the efficiency of vessels in terms of energy. At your electrical appliances, when you buy an electrical appliance at home, a refrigerator or a washing machine, anything, for example, you find a label which is classifying the energy consumption on this electrical appliance, and you can say, okay, yeah, this is an A+ or A++ or whatever that is. So it is considered an energy saving appliance. The same thing we try to apply for vessels from the design phase. So there is a design index, energy efficiency design index being introduced during the design phase for vessels, new vessels, or new designs, and which follows the vessels throughout their operational life by observing, by introducing an energy efficiency management plan, which has a few alternatives and a few options of what you can do on a vessel in order to decrease energy consumption on a vessel and make it more energy efficient, meaning that it will consume less energy. That means that it will consume less fuel, and that means less emissions. And this is recorded and monitored and reported to the authorities, and different authorities have introduced different ways of controlling this kind of emission. So if you will see, next slide, please. There are ways of collecting this data from IMO or a few European standards, the monitoring, reporting, and validating, or even trading emission systems. What energy you consumed for a particular voyage, you have an allowance. If you exceed that allowance, you've got to pay. If you don't exceed that allowance, you will have a benefit, a financial benefit, because you're very energy efficient. So there are regulatory ways, there are attempts around the globe to make vessels more efficient. Next slide, please. Other trends in order to improve the efficiency of vessels, and the efficiency not only of the vessels, but of the maritime industry as a whole. Taking advantage of the new industrial revolution, the fourth industrial revolution, which is a digital revolution. So introducing electronic documents rather than printing paper, becoming more sustainable, standardize the way that we exchange papers, we exchange documents, and minimizing trips just to see and check paperwork. Remote surveys were something that was introduced as an aftermath of COVID, in the same way that we introduced Zoom in our life. surveying of vessels remotely is a new thing that was introduced due to COVID, because surveyors could not fly to inspect vessels. And this is something that it is actually happening as we speak. Augmented reality or autonomous vessels are two new additional things, essentially improving the efficiency or improving the safety on board vessels. And again, we have other ways to improve vessel utilization by novel efficiency, augmented efficiency systems. Next slide, please. What we have left off are the two last points that I discussed originally of how the maritime industry affects the environment. And one of the two was migration of non-indigenous species. Well, one of the operations that are happening on vessels is to ballast, use essentially water to fill up tanks, mainly towards the bottom, the lower part of the vessel, just for stability. When the vessel is not loaded, when it is empty, we use ballast to keep it upright and steady. So we are loading water from an area. Then we are traveling somewhere far away in order to load cargo. At that area, at that loading port, we discharge this water and we load cargo at the place of where water was before, in the cargo hold. This exchange of water, pumping water in from one place, discharging it at a different place, it was liable for transport of many microorganisms and fishery non-indigenous not native to certain ecosystems, which essentially disrupt the ecosystem. And the recent thing at the maritime industry is to introduce ballast water treatment systems, which is essentially eliminates this transport of bacteria, microorganisms, or even fishery from one place to the next. So we are cleaning the water as we are pumping it into our ballast tanks. And my final slide, next slide please, would be the disruption of fishery with the noise that we emit out of the maritime activities. Marine life uses sounds to communicate with one another, to find prey, to feed essentially, to find mates, or to avoid predators, to navigate. We have seen, we are aware, or we are trying to understand those mechanisms of how these mammals are communicating into the sea by using sound. However, our activities, propellers running around, engines, survey vessels with hydrophone arrays, sonars, or sending various frequencies for exploration, are affecting those fish or mammals. And essentially, right now, we are doing essentially nothing to eliminate this kind of sounds. Hydrodynamic shapes or hydrofoils around propellers are assisting partially to that effect, but it is not eliminating the problem completely. Well, thank you very much for attending and for paying attention to how the maritime industry is affecting the environment and what we can do next. I shall pass for the final few slides the podium to my colleague Stella to finalize our own presentation. Thank you very much.
Thank you, George. I will continue very, very fast because I have to give the floor to Eric, and I think we have delayed Eric. Very fast, we'll go through some solutions for the marine environment. Just a time frame of the regulatory framework. Of course, there are other pieces of legislation that they are missing from this timeline, but these are some highlights, let's say, in the international regulatory framework. There is a small emphasis in the Mediterranean. We start from the Mediterranean in European Union because we come from this part. The European Union, was innovative in 1975 in establishing the MAP, the Mediterranean Action Plan, the Barcelona Convention, as it is known, for the protection of the Mediterranean Sea. And of course, in the latest years, we have an emphasis on the regulatory framework and on reports that are related to climate change, like the Paris Agreement, to how we should reduce emissions in order to protect the climate and the ecosystems, and to the IPCC reports, the reports of the Intergovernmental Panel of Climate Change. Of course, another solution or tool, you name it the way you want, is education, which includes research, education, specific education on the SDGs, education on the specific SDG related to the oceans, stakeholder engagement, raising public awareness, educating the open public, the people, in order to change their behavior for behavioral change. All these issues are issues that we are dealing with the American College of Greece. A lot of our students are doing research relating to the oceans, and we are involved in several activities. And we are very proud to be involved on volunteer activities as well, with our scuba divers team, who are cleaning the sea of the Saronic Gulf. The Saronic Gulf is the gulf around Athens, around Attica, twice per year. And we also have several beach cleaning activities offered by our students. There are technological solutions. George referred on them in much greater extent, especially the solutions on the maritime industry. Regarding the environment as such, of course, is treatment of all waste, wastewater, industrial waste, sustainable fishing techniques, anti-pollution technologies for removal of already existing waste and pollution from the sea. And of course, to declare more marine protected areas, areas in which several harmful human activities are restricted. And I would like to close just by saying that we cannot do research without appropriate monitoring. One of the most powerful tools that we have is ArcGIS. And there are also other monitoring tools, but we are very happy and proud to have our friend Eric with us to talk to us next about Esri and ArcGIS. It is a tool that has been used widely to map the populations of species, of threatened species, nesting areas, oil spills, pollution sources, illegal dumpings. The applications are endless. So I would like to stop here because Eric is the person who should talk about this. Thank you for following us, for watching us. And Eric, please carry on.
Excellent. Thank you much, Stella. And thank you so much, George, for a wonderful presentation there. I'll go ahead and pull up my screen, but just like we did before their presentation, I'm going to share my screen and also share a survey. I'm just really curious, who out there is using this GIS or mapping technology with their current work? So if you got your smartphone or mobile device, if you could scan that QR code, again, it's just going to ask, where are you from? What's your SDG of interest, as well as whether you're using any type of mapping technology or not. Now, I work for Esri, but I'm curious if anyone's using any of the different mapping platforms out there to solve any of their SDG challenges. So again, you can scan the QR code there, just 3 quick questions, or click on the link that I threw in the chat just a couple moments ago. There's a good number of you out there, so hoping for some good responses, as well as, again, having that opportunity to see our entire global community, where everyone's reporting in from. I know we had people all across Europe and Asia and the Middle East, Eastern Hemisphere, Western Hemisphere, Northern Hemisphere, Southern Hemisphere. So we'll go ahead, we'll give that a couple seconds for you to answer those 3 questions there and see what's coming in. And in the event you're not familiar with mapping or GIS technology, that's perfectly fine, because what I'm going to be talking about when I get my presentation started here is I'll set a level playing field for all of us about what exactly GIS is and how it can help. George and especially Stella there at the end started talking quite a bit about what it can do, and I'll be taking the perspective of not only oceans, but also how life on land impacts what happens in the oceans, because of course what happens in the oceans is not just simply happening in the oceans, it's usually as a result of, you know, something that's happening on land. But of course, I'll also talk about shipping as well, because that was an absolutely fascinating topic that George was talking about there. So what do we got here? We got so far 16 of you have chimed in, as expecting. SDG number 14, talking about oceans, is so far the most important. As well as coming in about 30% of you saying that you do use GIS or mapping software, and about 68% of you don't. So again, we'll just give this another minute or two. Again, you can scan that QR code with your mobile device, or check out the first link that I sent to you there in the chat. And if you even want to see this dashboard for yourself, you can go ahead and check that out. It's actually pretty cool, because you can interact with it. I can see, you know, where in the world people are using GIS, you know, here on the East Coast, and a little bit in Europe and towards the Middle East, but also where we have some of those nodes coming from. And maybe after today's presentation, I can make some of you reconsider a new piece of technology to consider using for your research, regardless of which SDG you're focusing on. So, all right, again, we've got an absolutely, you know, a fascinating spread of people from all over the globe. It looks like almost every continent represented here. So that's absolutely incredible that we're all working together. These truly are, you know, all the nations of the world being united around these sustainable development goals. So with that, you're welcome to keep submitting your surveys there, but I'm going to go ahead and jump into my presentation. And thank you again for your participation in both the first survey as well as in the second survey. And I'm just curious, where are people coming in that are interested in SDG 14? I can see we got some South America, East Coast, a little bit of Europe, as well as life on land. I'll be talking about a little bit. We can see out towards Southeast Asia, Australia, as well as Eastern United States. So a very cool way that we can go ahead and take a look at our data through maps. And that's exactly what my topic is going to be this morning. So let me go ahead and get my PowerPoint slide up here. And we'll get started. So again, good morning, good afternoon, good evening, good night, wherever you might be coming from for our presentations today. My name's Eric Wagner, and I'm a geographer. And as a result, the way I always want to go about trying to understand and study our world is through the lens of geography. You know, it's an absolutely fascinating way by which we can map our world, and it can really provide for a lot of insights. Both George and Stella showed a number of maps throughout their presentation that really highlights this, whether it was where species live in terms of their habitats, or George had that really great map about pollution going from Sri Lanka over to Southeast Asia. So maps can really be a powerful way of visualizing, analyzing, and understanding our world. So what do I want to talk about during my little bit of time here that I have with you all? Well, I want to provide a little bit of introduction into the topic here, you know, SDG 14 and 15, that there is this interrelationship between what's happening, you know, in the ocean and what's happening on land. Many times what's happening on land flows right into the ocean. But I also then want to talk about a little bit, what is GIS? Again, level set this for everybody. We'll go through some demos, some that are pretty basic, but I think could be applied by everybody, as well as one that's maybe a little bit more on the complex side that talks about exactly what George was mentioning about ships just staying at anchor in port for a long time, and what that means in terms of pollution, and maybe starting to find ways of quantifying that. And then, of course, providing everyone with some learning resources and tutorials to help you maybe get started with mapping, whether you're a pro or and a veteran, or maybe this is your first time hearing about GIS, what you can do to maybe better understand our world through this technology. So again, this idea that the current state of our oceans just simply hasn't happened because the oceans have polluted themselves. No, it's really because of what we're doing as humans, the anthropogenic change that we're bringing to these unique environments. And it's really this notion that what we do on land impacts what happens on the water. And understanding this scale of what happens is so important, and mapping can make it possible for us to better quantify and understand this. And one of the best ways to do it is through the geographic lens. Now, we don't necessarily need geography to understand that a city was small maybe 50 years ago, and then it grew larger, and more people probably meant more pollution, and more pollution probably meant more pollution in the water, and more water getting carried off to the local water bodies. We don't necessarily need technology to tell us that's pretty much a given. But again, if we want to better understand where this is happening, how this is happening, or when this is happening, suddenly we're going to need some tools to help us dive a little bit deeper into that. And GIS can make this possible. That picture over there that I have on the right-hand side is from some research I've done in the Caribbean, where you have some reservoirs that are in these mountainous streams. Water flows down from the mountain. It goes through some sort of city like Yaco in Puerto Rico on the southern coast, and then eventually makes its way out into the Caribbean Sea. Well, Yaco, like most other cities, has grown, and this has an impact on the local environment. And the local environment, it goes downstream out into the ocean, and suddenly that starts impacting the corals and the fish and all the other marine life that we see out there, and it just increases over time. So definitely an area that's certainly worth our time to study, better understand, and do so through a geographic lens. Now, the technology in particular that I work with and that Stella and George alluded to is known as GIS, or Geographic Information Systems. And the primary question that we ask with GIS is just simply where? Where does something happen? Where does something not happen? And so what this allows us to do is it allows us to understand trends across space, across the Earth. And it doesn't matter whether you're studying the smallest, most remote village in Africa, or the entire continent of Africa, or even the entire world. This works at the scale that's necessary for the type of work that you're doing, whether it's on land, on ocean, involving people, animals, environmental ecosystems, doesn't really matter so much. And what's most unique about studying things through a geographic lens is that way by which we visualize it. Charts, tables, and graphs certainly have their place. Even George and Stella showed some very powerful graphs of the information that they've collected with their respective research. But sometimes the most powerful way of showing data is through a map, like that map that George was showing of the satellite imagery of the pollution across the Indian Ocean. So on the right-hand side, those are actually some images that we'll see from our first demo. And what that is that's a watershed in Costa Rica. And what we can see is actually the land cover from 1992 and 2019. Most notably, that area in red is an urban area. And we can see that urban area is exploding. And so if we want to begin to understand how much an urban area is changing and where it's changing, we can begin to do that and understand, and even then know where that water is going to flow to. And understand, okay, well, that water is going to flow downstream. What's downstream of it in terms of maybe populations and people who rely on that for drinking water, as well as, of course, our oceans as well. But GIS eventually starts to ask more than just where, because once we start to ask where, we want to know why or when did that happen. So it just starts to open up more and more questions when we have this unique way of visualizing our data. So one thing I definitely want to mention, of course, is GIS is more than just a map, and it's also more than just SDGs 14 and 15, as I'm going to talk about here in just a little bit. Here there's a whole list of different applications of it. Stella mentioned a couple at the end, and so regardless of which SDG is of most particular interest to you, there's plenty of different ways that we can see GIS playing a role. Whether it's understanding land cover change, like I'm going to talk about, or maybe it's land and ocean animal tracking, Maybe household survey. Maybe you just need to know where your constituents are or your beneficiaries to whom you're giving resources. I've done this type of work across Africa in the past. And something we're all very familiar with is if we want to track disease, coronavirus saw a huge increase in uptick of use of GIS technology to understand where were people that were sick, where were these cases, and where were they spreading to? Again, where is that common question that we're asking throughout working with GIS? So this ArcGIS system, the one in particular that I work with, it allows for all different kinds of ways by which we can visualize, collect, analyze, share, and collaborate based on data. But to really kind of boil it down for today, we could say that we're able to collect data out in the field, again, doing something like that household survey. And then we can store it in a central online location where people can access it. And maybe that's an analyst who wants to start to dig into it, discover trends and patterns. Maybe it's then taking that information and sharing it with stakeholders and beginning to collaborate to then come up with data-driven decisions. Many times I see organizations that they just collect a lot of data, but they don't synthesize it to drive their business decisions. So that's something that's really important, that we don't just become rich with this data, but not really turn it into information. So that's something that's really powerful for us as well. And then of course, transparency is such a huge topic out there as well. How do we take this information and share it with the public? So that way it's not just, us as maybe nonprofits or governing bodies. How do we take that and share it out with the rest of the world? So I'm not going to touch on all of these topics today, but I will spend some time talking about doing some analysis and some sharing. Again, some that's relatively simplistic, that also some that's a little bit more complex, just to show that GIS has the ability to work, at all ends of the spectrum of performing analyses. So what's the first demo I want to take a look at? Again, it's watersheds. I've done a lot of work with watersheds, and that's how I found myself in this session, as a matter of fact, because a watershed is basically a basin that collects water before, effectively discharging it out to a larger body of water, which is something happening on land, impacting what happens out in the oceans. So we're going to take a look at San Jose in Costa Rica. And as I mentioned earlier, we'll see that as a watershed urbanizes, usually that's going to mean that the water quality is going to be impacted as well. So we'll take a look at how we can quickly delineate a watershed, trace to see where water is going to flow downstream, and then quantify how land cover has changed over time, and then start to get a more holistic sense of what type of biodiversity exists just off the coast of this particular area that might be impacted. And again, all this data I'm going to show here is freely and publicly available for you to work with. So I'm going to go ahead and I'm going to jump over here into an application known as Arcgis Pro, which really allows me to start to do some of these different analytics. And here I have the country of Costa Rica. I can see San Jose in the middle. And what maybe I've learned from some local scientists is that the area that I want to figure out what's upstream in the watershed is down here, as indicated by this blue dot, where this river flows down from the north, and this river kind of flows up from the southeast. So I want to determine what area is going to drain through this point before potentially making its way out into the ocean. But remember, GIS is more than just a map, so we can perform an analysis like this, where I can search through a whole series of tools that are available to us, such as a tool that allows me to quickly delineate a watershed. So if I have my point that represents, a watershed study point, I can quickly access that point, click run, and what I'll have in a matter of seconds is the watershed and what's going to be flowing through that point. So we'll just give this a second here to run. And what I can now quickly see is that anywhere a drop of rain falls inside of this blue polygon, it's eventually going to make its way through this point and flow downstream. And to make this a little bit more clear, I'll go ahead, I'll make that hollow just so we have a black outline of our watershed there. But now if I want to be able to do that tracing downstream, I can access a tool that's going to allow me to do that as well. And this tool works the exact same way. I can simply throw in that watershed study point that I have, run my tool, and what I'll quickly be shown is where this water is going to flow. So I know where it's going to go, where it's going to make its entry into the ocean, as well as maybe I might be concerned about any communities that are along that particular stream. So great, I've delineated a watershed. That's nice. But let's say I want to, again, dive a little bit deeper. How can I understand how land cover has changed in this location? Well, I can pull on all kinds of data sets that are available to me. And in this case, what I can do is I can pull on a freely available data set called global land cover. And it shows my land cover and how it's changing between the different years of 1992 and 2019. So right here on screen, it might be a little bit difficult to catch, but here's my watershed boundary, and here's that land cover from 1992. Most notably, the area in green is forests, and the area in red is an urban area. But what I can do is I can take this and I can look at it through different slices in time. And instead of looking at it in 1992, I'll take a look at it in 2019. And I want you to focus your attention in this general area right here. And what we'll see is this whole area, when it loads, has grown, and we see this incredible amount of urbanization in this particular area. And in case you missed that, here's that 2019, here's that 1992. So if I switch between it, you can really see that there is a big increase of urbanization. Again, this is just a visualization. We really haven't done much to quantify it. And that's what I actually want to go ahead and do next. And so there's all kinds of tools that exist out there, or tools that you can build yourself. And in this case, what I'm just going to quickly do is I'm just going to pull on a tool. And what it's going to do is it's going to take this land cover data that I have, and it's going to clip it or crop it down to my watershed boundary between the years of 1992 and 2019. And what it's going to allow me to do is actually understand the total area of all those different land covers and different land uses, and allow me to understand how much has it changed, how much has the forest area decreased, how much has the urban area increased. So really giving me this ability to, again, begin to quantify this type of change that we're seeing in these different areas. So it's going to take one more second to run here, but what we're going to end up with is going to be just land cover within my watershed boundary here. And I do apologize that this is taking just a second longer than I had anticipated, but my results are about to appear. And so there we go. So it's been trimmed down to my area of interest. So now again, we're slowly just going deeper and deeper and deeper into this particular area to better understand it. And what I can do is I can open up what's known as an attribute table for this. And what this is going to show for me is, for this particular data set, which is the 2019 land cover for this area, again, these different land cover classifications of what we see on the Earth. And what I'm able to see is, for my land cover, what was the total area in square kilometers in 2019, 1992, and what was its change? So I can see that, for example, areas that were mostly cropland, they actually decreased from 146 square kilometers in 1992 to 105, or total net change of minus 40. But what's most stark to me is I can actually see that areas of artificial surface, or urban areas, increased 152 square kilometers over roughly those past 2 decades. So again, just these ways that we can begin to quantify. But the question I want to ask now is, where have we seen this change? So I know how much it's changed, but where within this watershed boundary? And what I have the ability to do is a change detection, where I can take my 2 different land cover data sets for those 2 years and have the computer automatically compare the 2 of them for me to see where have we seen those changes in different land cover categories. So I can see what my land cover was in 1992, as well as in 2019, and only show those areas that changed to some type of urban area. And I'll run this. And now what I can see on my map is anywhere, get rid of this base map here to make this a little more clear, is anywhere that we see one of these little squares known as a pixel, anywhere that I see one of these, that area was not urban in 1992, but has become urban somewhere over those last 20 years. And if I want to explore how much that change has been, again, I can jump into the background information about this, and I can see specifically how much area, let's bring this in square meters, has changed from mostly cropland to urban area. And there's my total area. Or has changed from a particular type of forest to urban area. And that's the total area of it. So again, I can dive deeper and deeper and deeper, understanding where this change is taking place within my watershed. So we started off by just simply knowing that we have an urban area, but slowly but surely we shrunk it down to just the area of a watershed. Then we pulled in land cover data, figured out how much it's changed, and now even figuring out where it's changed. And of course, keeping this in the theme of understanding what's going on in our oceans, I'll pan over to the east here and turn my base map back on so we can see the ocean. Now, we can pull on all kinds of great data that's available to us from research scientists out there. Maybe, a quick data set that I pull on is just the number of, stony coral species, which are so important as an ecosystem service. And, I can see this isn't just a local data set, but rather it's a global data set. And by clicking inside of this feature right off the coast of Costa Rica, I can quickly learn that this area has, 28 particular species of this type of coral. Or maybe I want to better understand marine species patterns in terms of the rarity or the richness of different species in this area or anywhere else. So just off the coast of Costa Rica, I can see that, in terms of a species richness of fish, it has a score of 91, or the species richness of, mammals is a little bit lower at 57. So these are data sets that other people have pulled together and openly shared that we can use to better understand marine life in these areas that are a little bit downstream of locations that are seeing, large changes in urbanization on land not too far away. So let's go ahead back into the PowerPoint slide and take a look at, maybe another demo that we can do here that touches a little bit more on what Stella and George were talking about. And in particular, I want to talk about the Los Angeles as well as the city of Long Beach area, which George actually showed a map of during his presentation. And it's the idea of congested ports where ships are very frequently just sitting somewhere for a long period of time. How can we begin to detect that, understand it, and quantify it? GIS can help us do this with all kinds of different data types. So, so historically ships would actually, come to port, unload their cargo pretty quickly, and then go back out to sea. Their job was done. But due to COVID and staff shortages or backups at ports, these ships spent long periods of time anchored in the harbor, really just, whether they're dumping garbage or they're running off of their diesel generators, creating pollution for these local areas, both, for the air, the water, and local inhabitants. So what I want to do is I want to use a little bit of deep learning to automatically extract ship locations from satellite imagery that's freely available to help us understand where ships are located, but also at the same time, pull on what's known as AIS data or ship tracking information and help understand maybe how long some of these ships have been sitting at the same place, and then share this data through web apps. And speaking of web apps, there's a really great app that was made by one of my colleagues here at Esri. I'll just go ahead and I'll refresh this page real quickly. And what this pulls on is shipping data that was recorded up through, in this case, June of 2020. Not only is this a beautiful visualization, it's also extremely powerful in helping us understand some of what George was talking about and a point that I want to get to as well. So let's go ahead and jump in here to, before we go over to California, I'm going to go here into the Tampa Bay area of Florida. And instead of looking at cargo ships, I'm going to take a look at passenger ships. And I'm going to jump back to about the time that the pandemic started, if we can all remember back to March of 2020. And I'm going to zoom out a little bit. And it's easy to see where we have large quantities of shipping here, where the line is a little bit thicker and brighter. But if you can see it on your screen, there's some areas here of very faint lines that appear to be going in loops. I can click on one of these features, and what I can see is that this is a cruise liner that's 260 meters long. So this is a pretty big ship. And what's it doing? It's just going in circles because it's a ship that was waiting back at the start of the pandemic to get permission to go into port. Again, normally it would have just gone into port, but because of COVID and restrictions, here you have this big ship that's running its engines, going in circles to keep ventilation on the ship actively going. There's an environmental impact to this. So again, just ways that we can maybe share our information with the public is just so important and worth exploring. But we can certainly dive into this a little bit deeper from a geographic perspective as well. So what did I do? I went ahead and I downloaded some Sentinel-2 imagery. It's satellite imagery that comes from the European Space Agency. And what I was able to do is I was able to teach the computer what a cargo ship looks like. So now if I ever get more imagery from this satellite program that's freely available, I can now take images and automatically have the computer find for me these cargo ships. So literally what I did at first to train this model was I just said, okay, here's a bunch of cargo ships here in the area of Long Beach in California. And I just literally identified, just drew circles around all the ships and said, this is a ship, this is a ship, this is a ship. And the computer learned what those different ships were. And so what it allowed me to do was then take this imagery from different periods of time to start to monitor the number of ships that were sitting in port. So if I jump back into the web real quickly, I can make my own app, like a dashboard, just like the ones you saw earlier from the surveys you filled out. And this is a little bit cluttered, but what we can see over here was, based on the imagery that I had, was the number of ships per month that was sitting in the harbor waiting to offload. So for example, I could see that in February of 2021, there were 54 ships that were waiting off the coast here of Los Angeles and Long Beach. And if I wanted to, I could also pull on the relevant imagery from February of 2021. And we'll actually be able to see that this was how the computer was automatically detecting those ships for me based on that deep learning model. So if I have this interest in trying to understand how long ships have been sitting off of any port anywhere, I can train GIS to automatically do this for me. But here's the thing, this is just a satellite image. So it was really just one point in time. And so what I wanted to do was I wanted to better understand maybe how ships were sitting there for longer than just when that satellite image was taken. So I can bring in that same shipping data that we saw before, but it's not very helpful at the moment. It just tells me that ships were everywhere. This is those lines representing where ships have traveled. But if I change its transparency and give this a little bit more of an artistic flair, what I'll be able to see now is, again, where ships were more likely to have traveled. But what's most intriguing to me is you see these little horseshoe shapes or these little arcs over here. Well, what are those? Those are where ships just kind of stayed at anchor, and as the tide went in and out, the ship just rotated back and forth, pivoted on those locations. So if I overlay this ship tracking data that I have with the deep learning information about where I believe ships are located, what I can do now is I can determine for anywhere that I have one of my detected ships and where I have one of those arcs going back and forth, I can now click on it and it's going to automatically tell me which ship that was, if that information is recorded in the ship tracking data, and how long it's been sitting in that location. So if we wanted to start to quantify some of that pollution information, like George was talking about, trash being discharged, particulate matter being discharged, we can begin to understand that. Or, if I have an area here with a ship that maybe wasn't detected due to deep learning, or maybe that ship just wasn't there when the satellite took a picture, what I can do is I can very quickly just draw a box over top of that area of interest, click inside of it, and identify that this was a ship that's name was not being tracked, and it's been sitting there for about 30 days. So very quick ways that I can begin to pull on different data sets that are available to me, whether it's ship tracking data or satellite imagery, to dive a little bit deeper into how long some of these ships have been sitting in the same place. So to quickly wrap up, as we come here to the end of the presentation, again, GIS is more than a map. There's a lot that it can do, and it's not limited to just watersheds and ship tracking, but certainly that's what we focused on here today. And I certainly encourage you to take a look into what is possible in terms of working with GIS. And in the event you want to get started, what I'd highly recommend taking a look at is you can take a look for the Esri Academy or Learn ArcGIS, where we have all kinds of different lessons and tutorials that can help you get started with GIS if you want to do this mapping, whether you're a new user or you've been using it for a long time. And we have all kinds of blogs out there also to help you get a jump start on working with GIS and seeing what some of the professionals are doing. I've certainly taken many ideas from them as well, and they can help you out as well. As a quick example, this is our Learn gallery where I just searched for the topic of oceans, and we have all kinds of different topics here that are available to us, whether it's exploring coral reef habitats, fishing in the Bering Sea, or hurricane storm surges, ocean measurements around the world, all kinds of different lessons that provide step-by-step instructions to help you get started and do mapping and change our world. So with that, I'd like to thank you all for your time. I know we're butting up against it, here from our perspective. But it's been great having you with us here this morning. On behalf of myself and George and Stella, thank you so much for joining us. And with that, I'll conclude my presentation. Thank you, everybody.
Thank you, Eric.
Excellent, excellent, amazing piece of information.
I don't know if
I was
we
really
have more
interested.
time. Do we have more time? Do we have time for questions? Maybe I've tried to answer some questions in the chat.
I mean, yeah, I'm not exactly sure what the schedule is for the SDG conference, but I have a little bit of time if we want to scroll back through and see if there are any questions that came in from any of our presentations this morning.
Maybe
we can go through up until 10:30.
Oh, perfect.
All right, okay. I've answered a couple of questions in the chat, in the questions and answers. So I think we shouldn't go through them. There was another question in the chat by someone asking if SDG 14 is only about the oceans, and if this does refer to other aquatic bodies, that they are freshwater aquatic bodies. SDG 14, as it has been defined by the United Nations, is primarily focusing on the oceans, and this session was on the oceans. But of course, under this goal, we can discuss life underwater for freshwater ecosystems. Freshwater ecosystems can also be included and discussed under SDG 15, which is life on land, because it is there where we discuss the terrestrial ecosystems, and lakes and rivers are part of the terrestrial ecosystems, not the ocean ecosystems. So it is, you know, a little bit in between. It is a matter of how someone defines the borders of a particular SDG. Very good comments, Eric. Excellent presentation.
Yeah. Hey, can I introduce someone here real quick who joined? I think she was dropping some kids off at school this morning here on the East Coast, but I actually have a colleague with me, Carmel, who actually does a lot of work in the nonprofit area. And actually a question came up that might be relevant to you, Carmel, talking a little bit about GIS and some licensing in case anyone's interested. So Carmel, do you want to give yourself a quick introduction and maybe take that question for us?
Sure, thanks. Great presentation, Eric. Great to see. I even learned some things, and I've been working at Esri for a couple decades. We do have a number of tools and technologies. They go from like free developer tools and some specific applications that are free that many of our customers and ourselves have created, all the way up to, you know, really advanced systems and enterprise tools, you know, for doing like managing satellite imagery and things that you've seen the results of here in this work. So I'll put a couple links in the chat for you all to take a look at, and you can, you know, always go to arcgis.com and click on the map. Even if you're not logged in, you can get a public account there, but even if you're not even logged in and don't have a public account, you can explore a lot of the data. You just can't save things and all. But with a public account, you can actually, you know, utilize quite a bit of the technology. And then there are options like a personal use license is around $100, depending on your local taxes and things. But it's about $100 for a personal use license. And I'll also put that link in for you. Thanks.
Thanks, Carmel. You know, we can scroll through this here, see if there are any more questions, but if anyone had a question that maybe wasn't answered, if you want to maybe repeat it in the chat again so we can see it down at the very bottom, I'm more than happy to take any questions about any of our presentations.
Well, Eric, from what I see, there is a question about you again, about the GIS to detect sick fish.
Let's see here. What time did that come in roughly, George?
No, it is on the Q&A. It is the
Oh,
last
it's
one.
in the Q&A. Let's see here. A question. Can we use GIS to detect the sick fish in the ocean? Thank you. So a great question. I don't necessarily know if you'd be able to detect the sick fish in the ocean because, if you're trying to, it really has a lot to do with the size of a feature. So for example, I was taking a look at, cargo ships, which are, these massive features, which are, it can be like we saw with that one cruise liner, up to, 300 meters long or bigger, depending upon the shipping. So I'm trying to find something individual, trying to find something big like that is certainly possible. But, I don't necessarily know how possible it would be with, something maybe any smaller than like a whale or something of that nature. But if you're in an area where maybe you're seeing some form of like maybe a die-off of species or something like that, where they're washing up on a coastal area, if you were to do some sort of survey with high-resolution imagery, maybe like a drone or maybe through some other local aerial surveying partner or company, you might be able to pick up that kind of information and again do detection. I actually saw a really cool example. This was a while ago where what they actually did was they were feeding fish in an area, and what they did was they flew the drone over it, recording the video, and they used deep learning to automatically detect where the fish were in the video. So they had a drone probably only maybe 30 feet up in the air, looking down there, and as they were throwing food out into the water, the fish were coming up, and deep learning on that video was automatically figuring out where those fish were, and then they were able to lay that video on top of their map and see where those fish were. But that was for a relatively small geographic area. That wouldn't be for something like an entire ocean or even an entire bay or harbor. So what I would ultimately say is if you're looking at larger species, possibly smaller species of fish, maybe, but in a relatively smaller area. So that's what I would say for taking a look at that. Great question.
May I add something on that, Eric?
Oh, sure, go ahead.
I think you're right, because it is very difficult to detect the fish which is sick. I mean, even a biologist could not say if fish is sick just by looking at it inside the water. So it is very difficult to detect. It is different if we are talking about dead fish, which floats on the surface of the water, or it has been washed out on the coast, and different about fish that swims. I mean, we need technology and satellite technology and drones that they are so sensitive that they can take very accurate pictures underwater from the air to underwater, and then someone would need to examine and identify, signs of sickness, which are not always obvious. I mean, we cannot always say that a fish is sick just by looking at it. So from the environmental and let's say the biology side, this is very difficult. It would be very nice if it was doable, but I think it is very, very difficult. A very good idea, however, maybe in the future.
Hey, you never know. Technology is constantly evolving.
Exactly. Someone asked about volunteerism and what could we suggest about volunteerism. There are so many organizations, NGOs and global organizations, that they undertake a lot of activities and initiatives on volunteerism. So I would propose that each of us looks around their own community and identifies such organizations in their own community and joins these efforts. I mean, we cannot talk about a global effort in volunteerism or one organization that is better than the other, because we would be really unfair to many other people and NGOs that they do very good work. Do we have any other questions? Okay. I assume we do not have more questions. Is that right? Should we finish the session?
Yeah, I don't see any more questions. If there are any more, you have sent all information on the website or your contact information, so I think that should be fine. Thank you so much for all joining us today, all the participants, and for the speakers for your great presentation. I think we'll be getting a lot of feedback in the chat that it was very interesting, interactive for everyone. So thanks again, and I think we can end here.
Thank you.
With everyone.
Thank you, everybody.
Have a great day, everyone.
Thank you. Bye-bye.